Hello friends, in this video I am going to explain you what is modularization, and also we will understand what is the model coupling. The modularization is a technique or a method which is used to divide a software system into multiple discrete and independent modules which are expected to be capable of carrying out the task independently. So these modules may work as a basic constructs for the entire system. Designers tend to design the modules such that they can execute or compile separately and independently these modules. So this is unintentionally follows the divide and conquer rule for problem solving strategy. This is because there are many other benefits attached to this modular design of a software. So therefore, the software system is divided into multiple discrete and independent modules. So each module is independently carry out their functionalities or their task. Let us understand the disadvantages of the modularization. When we are dividing our system into number of pieces and naming as the modules, always the modules are very small enough to manage. So this is the first advantage. So smaller components are easier to maintain. Second is the program can be divided based on the functional aspects. So we divide our system on the basis of the functional aspects. The third advantage is desired level of abstraction can be brought in the program by dividing the system software, the system. The components with high cohesion can be reused again. And also the concurrent execution can be made possible. Because when you implement the number of modules in your system, when the system is divided into modules, at a time when you want to execute the code of the two different modules, that can be made possible. That is the concurrent. So concurrent facility we can get it in the modularization. And also the desired from the security aspects also, the modularization is the best one. So these are the some of the advantages of the modularization. What is mean by module coupling? In software engineering, the coupling is the degree of interdependence between the software modules. The coupling means the interdependency between the software modules. The two modules that are tightly coupled are strongly dependent on each other. Tightly coupled means all the functionalities, the interfaces, the functionalities, everything is strongly coupled with two modules, means one module cannot independently perform the task because it is coupled with other module, hence it is dependent on the other module. However, the two modules that are loosely coupled are not dependent on each other. When the loosely coupled the two modules, those will be the better for the software. So uncoupled modules have interdependence at all within them. So uncoupled modules have no interdependence at all within them. It means that when you don't have any coupling with the two modules, so what happens? They are independent, they are not dependent. So the two modules are not interdependent, so they are independent and they are dependent on themselves. Now, these are the some of the various types of coupling techniques. You can see in the first figure, uncoupled means no dependencies at all. Every module is independent and every module is capable enough to perform their own task independently. So they are not dependent on each other. Whereas the number B figure shows loosely coupled. Loosely coupled means some dependencies are there, not many dependencies, some dependencies are there. So therefore it is called loosely coupled. And when it is highly coupled, then we say that many dependencies. So it is highly dependent on the other module. Okay. A good design in now see, a good design is the one that has a low coupling. Why we say low coupling? Because if we have low coupling means every module is independently, they can function, they can work, they can perform the task. Coupling is measured by the number of relations between the modules. So coupling, it will measure how many number of relations a module has with others. That is, the coupling increases as the number of calls between the module increases, or the amount of shared data is large. Thus, it can be said that a design with high coupling will have more errors. So when we have loose coupling, it would be good for the designing point of view, because we will be having less errors. So these are the types of module couplings. So you can see, if there is no direct coupling, every module is independent, then we can say it is the best one. Okay. And the worst scenario is the content coupling. So for each and every content, we are dependent on other module, then we can say that it is a worse coupling. Okay. Now we can see here there is no direct coupling. It means that one module is not dependent on other module. You can find here we have M1 and M2. There is no direct coupling between M1 and M2. In this case, modules are subordinates to different modules. Therefore, no direct coupling. The second is data coupling. When the data of one module is passed to another module, this is called the data coupling. Now you can find we are passing the data from M1 to M11 and M12, or we can say that M11 and M12 data is passed to M1. So this is called as data coupling. Stamp coupling. When two modules are stamped coupled, if they communicate using the composite data items such as structure, objects, etc. So when the two modules are using the same structure or object and composite of the data items, and they are communicating with that common structure or object, then we say stamp coupling. When the module passes non-global data structure or entire structure to another module, they are said to be stamp coupled or coupled. For example, passing structure variable in C. So passing structure variable in C or object in C++ language to a module means whenever we want to access the methods or the data members of a class in a C++, we have to create object. With the help of that only we can access the members and the member functions. Similarly, passing structure variables in C. So when you declare a structure in a C, you should have a structure variable also to access those structure data. Okay, so that is called the stamp coupling. Control coupling. Control coupling exists among two modules if the data from one module is used to direct the structure of instruction execution in another. Then it is called control coupling. The external coupling arises when two modules share an externally imposed data format, or we can say communication protocols, or the device interface which we are using for the modules. If all the modules or the two modules are using these external communication protocols or device interfaces or the data formats or the structure, okay, then we say that external coupling. This is related to communication to external tools and devices. The sixth is the common coupling. Common coupling means when the two modules are accessing the global data. As shown in this figure, two modules are common coupled if they share the information through some global data items. So here M1 and M2 both are sharing the same global data. So therefore, if these two modules are called as common coupling module. Contained coupling. Contained coupling exists among two modules if they share code, that is, a branch from one module into another module. Then we say contained coupling. So these are the different couplings we have in module couplings. And after the module coupling, the next is the module cohesion. In computer programming, cohesion defines the degree to which the elements of a module belongs together. Now here cohesion means the degree to which the element of a module belongs together. Means in a module, how tightly the module elements are gathered or they are coupled within the module. I'm not talking about the different modules. I'm talking within the modules, how the elements are gathered. So that is nothing but the degree of the cohesion. The cohesion is nothing but it is the degree of the elements of a module belongs together. Thus, the cohesion measures the strength of the relationship between the pieces of the functionality within a given module. For example, in highly cohesion or cohesive systems, the functionality is strongly related. The functionality within the module is strongly related in the cohesion. So cohesion is an ordinal type of measurement and is generally described as high cohesion or low cohesion. We can measure either it is a high cohesion or low cohesion. Okay. So ordinal type means we describe whether it is having all the elements together, all the functionalities within modules and their relationships are strong or weak. So always we say that for the better designs, the cohesion should be high and coupling should be low. Now, here you can find the module strength. How we can find the module strength? The elements togetherness shows the module strength. Okay, cohesion equals to strength of the relations within the module. Okay, the strength of relations within the modules means how we have the relationships among all the elements of the same module. That togetherness, that relationship among the functions of the particular module shows the cohesion. So therefore we say that the cohesion equals to the strength of relations within the modules. Now these are the different types of module cohesions we have. If we have functional cohesion within the module, that would be the best one. If coincidental cohesion is there, that is the worst case or the worst cohesion we can say. Okay, so the first one is the functional, that is called as the one of the best one or ranked one. Ranked 2 is the sequential cohesion, ranked 3 is the communicational cohesion, and ranked 4 is the procedural cohesion, Ranked 5 is the temporal cohesion. Sixth rank is the logical cohesion. And the seventh and the most worst cohesion is the coincidental cohesion. So here you can understand what is mean by functional cohesion. So functional cohesion is said to exist it in the different elements of a module cooperate to achieve a single function within the module. Whatever the functions is existed and different elements of that modules and their cooperation to achieve a single function or a task, that is called the functional cohesion. Sequential cohesion. A module is said to be possesses sequential cohesion if the element of a module form a component of a sequence where the output from one component of the sequence is input to the next one. It means that the programs are always in a sequential manner. Similarly, the sequential cohesion, if the elements of a modules form the component of the sequence, then we can get the output in that sequence only. So therefore, where the output from the component of a sequence is input to the next, it means that one after the other, the sequences which you have in the modules, if one cohesion is giving the output which is the input for the next one, the next element's input, and next input is given to the next element, and thereafter the elements which generates the output which is used for the another input, another element as an input, then that kind of output from the component which is in a sequence is called as the sequential cohesion. Communicational cohesion. The module is said to have the communicational cohesion if all tasks of a module refers or update the same data structure, that is, the set of functions defined on an array or a stack. Procedural cohesion. A procedural cohesion if a set of purpose of the modules are all parts of the procedure in which a particular sequence of steps has to be carried out for achieving a goal. For example, if you are using the algorithm for decoding a message, then we say it as procedural cohesion. Temporal cohesion, which includes the functions that are associated by the fact that all the methods must be executed in the same time. The module is said to exhibit temporal cohesion. And the sixth one, logical cohesion. A module is said to be logically cohesive if all the elements of the module perform a similar operation. For example, error handling, data input and data output, etc. So for the module, we are applying the same logic to all the elements of the modules to perform a similar operation. Then we say that module as a logical cohesion module. The final one is the worst cohesion is the coincidental cohesion. A module is said to have coincidental cohesion if it permits a set of tasks, set of tasks that are associated with each other very loosely. Then we say that coincidental cohesion. Okay. There is a difference between coupling and cohesion. So now you can find there is a table which shows you the difference between the coupling and cohesion. As we know that the coupling is also called the intermodule binding because we are using the two modules and we are connecting those two modules together. So therefore, the coupling connects the two modules. Therefore, we say that it is an intermodule binding, whereas the cohesion is also called intramodule binding. Intramodule binding means within the module, whatever the elements are there, so we are binding those elements in the cohesion. The second difference is the coupling shows the relationship between the modules, whereas the cohesion shows the relationship within the module. Okay, coupling shows the relationship between M1 and M2, module 1 and module 2, whereas the cohesion shows the relationship within the module 1 elements and module 2 elements. So if you have module 1, so it will show the cohesion shows the relationship within the M1 module. Third is the coupling shows the relative independence between the modules, whereas the cohesion shows the modules relatively or relative functional strength. Fourth is the while creating the coupling, you should aim for low coupling. That is, dependency among modules should be less. Whereas in cohesion, while creating, you should aim for a high cohesion. That is, a cohesive component or a module focus on a single function. Okay, because a high cohesion will give you the togetherness of the elements within the module. And the last difference between the coupling and cohesion is in coupling, modules are linked to the other modules, means one module is linked with the other module, whereas in cohesion the module focuses on a single thing. Okay, it will focus on a single thing rather than linking with the other modules. So these are the some of the differences between the coupling and cohesions. So this is all about the coupling and cohesions, the module coupling, modularizations, the advantages of the modularizations, module coupling and cohesions, and the difference between the coupling and cohesions. So kindly like, share